Welcome MCT4C folks to the infamous missing example video. This is example 2 from our 3.1 vectors video, and I'm hoping to get through it pretty quickly. A word of warning here, I've got my weapons of math instruction here, my protractor and my ruler, and it's not going to match what you have because, well, it just won't. It's whatever I press there, but we'll get the same idea. In order to use a scale diagram of a vector, notice we've got the scale written there, I need to actually measure, and so I'm going to see if I can manage to do that. Measure this, the length of this thing. There we go. See if I can get that to bend down. That looks like it's about 6.2, so I'm going to write that in there, 6.2 centimeters. That's not the actual number of newtons, though. 6.2 centimeters is 6.2 centimeters. Don't know why that's red, but that's okay. We'll go with red. 6.2 centimeters. But what is that? Well, to get from 1 centimeter to 6.2 centimeters, I have to multiply by 6.2. So I have to multiply this one by 6.2. So that's 50 times 6.2, which is, get my calculator out, 50 times 6.2 is 310 newtons. And then notice I have to also measure the angle. So I'm going to move this aside and measure the angle. Now this one's a little bit strange because this is one of our bearings or headings that we studied, and this one's from the vertical, or sometimes from up, we would say. And I need to sort of move this around so I can use this protractor. There we go. And that angle looks to be about, get her in the right spot there, I'd say about 108. Move this aside. And that's around 108 degrees. So theta is equal to about 108 degrees. About. And so my vector u is the magnitude and the direction. 310 newtons, 108 degrees. And without anything else said there, it's known that it's from straight up or from north or from vertical, that it's this angle in here. Okay? And for the other ones, I've measured them, so I'm not, you don't have to watch me fumble around with these two things for the entire video. I've actually measured them, and I'll talk about them very, very quickly. Notice I measured these with a different ruler, so it might not be exactly the same sort of thing, but the angles will be okay. If this is 4.7 centimeters, and I multiply by 120 kilometers, I get my velocity. And of course, when you measure with the ruler, it's going to be different. It's a different scale when I'm using the smartboard software. But if this is 50 degrees here, there's a few ways I can describe that angle. 50 degrees north of west. Well, straight left would represent west, and so 50 degrees north of that, I could write it just like that. Similarly, and this is probably my faves, it's my faves, north, and then this is 40 degrees because each quadrant is 90 degrees, north, 40 degrees west. That's another way to measure it. Or I could measure this entire angle around here, which would be 270 plus 50 is 320, or all the way around 360 minus 40. And we can see the third one is very similar with the extra little mess about it was measured in millimeters instead of centimeters. So when I measured in centimeters first, I had to change that to millimeters, and then I got my vector. Remember, the vector includes both the magnitude and the direction. Okay, so for homework today, you'll have to find a protractor and find a ruler and draw some scale diagrams. And that's it for the famous missing example video.